In this lesson, we would understand how to determine the slope and the equation of the tangent drawn to a curve at a given point. Let's say we are given the function fx equal to x squared minus 3x, and we are asked to determine the equation of the tangent drawn at this given curve at x equal to 2. The method that we will be using here is called the first principles method. If we assume a rough sketch for this curve to be this, and we are asked to determine the equation of the tangent drawn at x equal to 2. So let's say that lies here. If this one is x equal to 2, when we draw a tangent to this point at x equal to 2, this is how the tangent line looks like. Now the question basically wants us to find the equation of this line, because the line equation can be written in general form as y equal to mx plus b. We are basically looking to find m and b of this tangent line. The first step towards solving this is to find the slope m, and the process we will be using here is to find m with the help of first principles method, or that is also called finding m with the formula called difference quotient. Difference quotient looks like limit h approaches 0, f of a plus h minus f of a, the whole thing divided by h. As we are given f of x is x squared minus 3x, therefore f of a plus h will be equal to a plus h squared minus 3 times a plus h. That is, wherever we see an x, we will substitute a plus h for that. A is nothing but the point at which we are finding the slope, and in this case it is 2. If we substitute that in here, we would be able to get f of 2 plus h, so that would be 2 plus h whole square minus 3 times 2 plus h. Because this represents a plus b whole square, so we can apply the formula for a plus b whole square. That gives us a square plus 2 times ab plus b square minus, we expand this and we get 6 minus 3h. When we simplify it, we would be able to get 4 plus 4h plus h square minus 6 minus 3h. Simplifying it further, we would be able to get 4 plus 4h plus h square minus 6 minus 3h. We don't have to put a bracket, and we can collect like terms. So we would be able to get h square, that is this one. Then 4h minus 3h gives us an h, and 4 minus 6 gives us a minus 2. So after simplifying f of 2 plus h, we are able to get h squared plus h minus 2. Similarly, we can solve for f of a, which is nothing but f of 2. This can be done by substituting 2 in place of x, and the equation that we will be using is the original one, x squared minus 3x. So we get 2 squared minus 3 times 2, which gives us a 4 minus 6, which is negative 2. Therefore, we get f of a equal to negative 2. As we know, slope is equal to limit h approaches 0 for f of a plus h minus f of a over h, and we have got f of a plus h as h squared plus h minus 2 and f of a as minus 2. We would substitute these into the formula. So this would give us limit h approaches 0, h squared plus h minus 2. Negative and negative gives us a plus 2 over h. We can cancel this out, and we would be finally left with limit h approaches 0, h squared plus h over h. To simplify it further, we can factor h out of this. This is what we get after factoring h out of the numerator. We can cancel this and this out, and finally we will be left with limit h approaches 0 with h plus 1. Since now we know how to solve for limits, and we know substitution is the first step that we do towards solving limits, so we would substitute 0 in here, and the final number that we get is 1. Therefore, the slope for this particular tangent line that we have got here is 1. If we were asked to find the slope of the tangent drawn at x equal to 2, then we would leave this as the final answer. Since we are asked to find the equation of the tangent line, so we would proceed further by completing the equation line, and that will be done by solving for b value. We know in order to solve for b, we need to substitute m, x, and y. M we already have is 1. Let's understand how to get x and y, and let's go back to the original question graph that we had made earlier. If we notice here, this point is where the tangent is drawn, and this point has coordinates 2, that is the x coordinate. To solve for y coordinate, we need to solve for f of 2. So this is f of 2. And we already calculated f of 2, that was this value here. F of 2 is -2. Therefore, the point coordinate for this is 2, -2. And we notice this point 2, -2 is common for both the curve and the tangent line. So to find the equation of the tangent line, we would substitute x as 2 and y as -2. So we substitute here y as -2 and x as 2, and we solve for b. When we multiply 1 with 2, we get a 2 plus b equal to -2. So b we are left here is with -2 minus 2. That is equal to -4. Using this b and the m value that we got before towards writing the final equation, we would be able to get the equation as y equal to 1x minus 4, or we can write it as y equal to x minus 4. And this is how we get the equation of a tangent line drawn at a given point on a given curve.